Hello everyone. Now we are going to learn a very important topic, that is different way of creating mathematical model in Etabs. Now very important thing you have to observe that I have used one word, that is mathematical model. Instead of using word mathematical, I may say that simply that different way of creating model in Etabs. But why we have used this word mathematical? First of all, we will understand this meaning of the word. The word mathematical came from the word mathematics. In mathematics, you know that we have different equations, we have different quantities. Like that, in Etabs also, when you make the model, it also contains some values. When you make the model in Etabs, the model will contain some values. If you're making the columns, then definitely the columns will have some torsion values, axial force values, shear force values. Like if you make the beams, then beam generally will have bending moment values, shear force values. It will also have the torsions values. Like that, whichever things you are making in Etabs, it is going to have some mathematical values in that. Means it is going to have some quantity in that. So let's suppose that I'm just opening any Etabs file to show you this. Right now I opened a mathematical model in Etabs. Why I'm calling this model as a mathematical model? Let's suppose that I have a column here, and in this column I will have some axial force values, I can have some bending moment values, I can have some torsion values, I can have a shear values. Like that, for every element I can have these all the values. In the beam also, in the shear wall also, in the cell also, like slab also. In slab you will have a bending values, you will have the stresses values, you will have a strain values. So these are the values which you are looking, it has some quantity in that. So let's suppose that if I am going to look at the column axial force values, so I can go to display frame forces and I can select the combo option and I can look at the axial force values. So if I will just select the columns and do the right click to this, I can get the axial force value here. Now you can look at that this force which you are looking is in the form of kilonewton, and it has some values like minus 6428.6906. So minus sign is generally indicating that the forces is in compressions. So we are getting some values, right? We are getting some quantity here, we are getting some values here. Now to get these values, there are different metric equation has to be solved for the bending moment also. So these all the things are happening is due to the mathematics only, right? So there is a mathematics involved in that. So there is a finite element analysis has to be get carried over here by the software, and through that you're getting some mathematical values here. Now that's the reason why we can call this as a, like this model is a mathematical model, or even we can call that this model is analytical model also. So analytical model also we can call it, there is no wrong calling this model as analytical model. Anytime you run the analysis to get these values, software is going to solve the equation. So what the equation software is going to solve, I am going to write here that the equation is Ku is equal to F. This is the linear static mathematical equation that software need to be solved to find out the quantities. So software need to solve this equation to find out that what is the displacement coming to the structures, what is the axial forces coming, what is the bending moment coming. Software will solve these mathematical equations to find out an important quantity that we required for designing our structures. Now this is very simple to understand that we require to solve the mathematical equations to find out that what is the axial force coming, all the important quantities I am talking about need to be find out by solving these all the equations. So to get these quantities, what we are doing? We are solving the mathematical equations to find out these all the quantities, right? So this is things only are happening. So when you are making the columns, it will have some values in the form of stiffness. When you are applying the forces, when you are applying the loads, it will have these values in the form of forces. Then from this equation we can get that what is the displacement coming. So when you know the displacement, then we can find out that what is the strain, what is the stresses, what is the axial force. So these are the important quantity, we can get it from this. So software is simply solving these equations. Don't think that it is solving a simple equation. Inside this there are a lot of matrix is to be created, and by that help we are getting all these quantities. If you remember that in college time or in a school time, if you used to solve the mathematic equation, a small mistake if you done in equations, then final result is going to be wrong only. So like that here also, if you done a very small mistake in making the mathematical model, the final model or final result which you want to look at is going to be wrong only. So you have to accurately make your mathematical model so that it should be error free, it should not get any wrong result. If you done a small mistake also while making the mathematical model, then final result is going to be wrong only. So you have to accurately make your model. That's the reason why we have to know that what are the different way that from which we can create the mathematical model so that the result coming from the model should be accurate. Before going into deep in topic, one very important information. A SpanStruct has released PG program in structure design and analysis. In this program, you will be learning Etabs, SAFE, RCDC, Rivet and CAD in very detail. In this program, you will be getting live classes, pre-recorded sessions, quizzes, project submissions and checking, and also you will be getting a personal training also. Also, you will be getting dedicated career service which help you to provide placement in top companies. Our student is placed in top companies in India, also in abroad. Also, if you want to open your own consultancy, our program and team will help you to achieve that goal. Also, this program is designed for the working professionals. Also, it is designed for the student also. So you will be getting a dashboard here, and in this you will get an enroll course here. After clicking in enroll course, you can start learning this. So this is the curriculum which you will be learning in this program, and in this curriculum you will be doing total 4 projects. Also in this program you will be getting live classes for the discussions and solving your doubt. For the demo class, open our website, that is SpanStruct.in. You will get a link in description box also. And after that you just need to fill your name, email address, WhatsApp number and choose your date, time and schedule your live class. You can also make a program related inquiry on given number. Looking forward to see you in our course program. Now come back to the topic which we were discussing. The first method is your through grid lines. So what you can do, you can create grids in Etabs like this. And through this grid you can create mathematical model in Etabs. In this grid line method you can make the grids either in Etabs or even you can make the grids in CAD software also. If you're going to make the grid lines in the CAD software, after making you can import in Etabs. So I will show you the options from where you can import. So if you're going to open the Etabs here, this is the grid lines which is created by the Etabs only. So we can easily create the grid lines through the Etabs. But if you want to create the grid lines, very complicated grid lines, then it is very difficult to create in Etabs. You have to calculate and you have to create it. So what you can do, you can easily create the grid lines in CAD software, and after creating it, you can import in this Etabs software. You can go to edit option. Here you will find edit storage and grid system. You will click this, then you will find a grid system. So this grid which you are looking right now, it could be managed by modifying this. So this window which is coming just in front of you, from this you can manage this grid which is there in Etabs. Now I will just cancel this, and if you want to import the CAD grid lines, then you can do add from .dxo file option. You will click on this option and you will select the CAD file on which you have made this grid system, and you will select and you will import it. So this is also very easy method through which you can create the mathematical model in Etabs. After importing the grid lines in Etabs, you can start modeling your columns. So what the column you want to take it, you can start modeling the columns. You can start modeling the beams also. You can start modeling the slab also. So you can look at the 3D. Now after making the grid lines, it is very easy to model all the structural element in Etabs software. Anyhow, in the upcoming lectures, we will model complete one project through this grid line method. Now I will come back to the another method of creating the mathematical model in Etabs. Now let us look at the second method, importing .dxf beam centerline plan. Now this is the very important method, and maximum of the project you will be using this method only. Now in this method, what is happening here, that we are going to create a beam center line. So as you know that we get the architectural plan from client, then this architectural plan has to be get converted into a structural frame plan, and after creating the structural frame plan, there the beam center line has to be made. So I will just show you. Right now I am in the CAD file and I am showing you the architectural, structural and the beam center line of this project. Now the first thing you will get from the client, that is your architectural plan. And this architectural plan has to be get converted into a structural framing plan. And after creating the structural frame plan, you have to create the beam center line plan. And you have to import this beam center line only. So you can copy this beam center line and you can make it into another CAD file and save this file into .dxf file extension, and after that you can import in Etabs. In upcoming lecture of this course you will find that complete procedure how to create the structure frame plan, how to create the beam center line plan is explained. Also you will find that a complete procedure that how you can import the .dxf floor plan in Etabs is also explained. So right now I'm not going to explain you. This explanation you will find in upcoming lectures. Now I will come back to the third procedure from which you can create the mathematical model. Now let us look at the third method by importing .dxf and .wg architectural plan. Now this method is not similar to the beam center line method. Don't think that this is going to be similar only. There is a little bit change here. What is happening? In this we can import .wg file also, but here we are importing architectural plan. So there we need to change something in the architectural plan, some changes we have to do it. After doing the change, you can import this in Etabs. In upcoming lectures, we will do one project where we will create mathematical model through this method, where we will discuss more deeply that how the procedure we have to do it, how we can convert this architectural plan so that it can be imported in the Etabs. So these are the important things we will look at that time only. Now let us discuss the fourth method, which is by importing .dxf 3D file. In this method, we will import .dxf file extension, but we will import the 3D file here. In all this method, when you are going to import CAD file, we are going to import the 2D here. But in this case, we will import the 3D file here. Now I am going to show you in the CAD software how this 3D file looks. So this is the 3D file of one of the project where you can import this file directly in Etabs, and you will find that all the beams, columns, shear wall is already made in Etabs. You need not to make it once again in Etabs, it is already made in CAD software. So all the things is already modeled in the CAD software, you only need to import it. But making this CAD file requires a lot of good knowledge of 3D in CAD software. So if you are very good in making 3D in the CAD software, then you can easily make it. But if you don't have that much of the knowledge of the 3D in the CAD software, it is very difficult to make it. I will not recommend you to use this method extensively, but I will show you that how you can import this 3D file directly in Etabs, and further you can do the analysis and all, and you can remove the errors if it is coming. So what you can do, you can open the Etabs and you can take a new file here. This you can keep it blank, give it OK, and make sure that the 3D file which is opened, it should be get closed. Now you can go to the file, you can go to the import option. Here you will find .dxf file of 3D model. You will click on this. You will select that DXF file here of 3D. You will give it open up. After that, the coordinate system will G1 only. The DXF file unit, you have to keep it in mm. You select all the layers and you give it OK. So all the height and all it will take automatically how you made it in the CAD software. On the basis of that, it will take the height. After that, you give it OK. It will ask you to save this file. You save it. Close one of the view. Now look at model is created within few minutes by clicking few steps. Further you can apply the load and get the result. Now very important thing you have to observe that while importing or while making the CAD file in the 3D, there might be some mistake has been done. So this mistake has to be rectified in Etabs. So you always need to check the warnings and you have to remove the warnings which is created in Etabs. Anyhow, we will do one project where we will import the .dxf 3D file in Etabs, and further we will run the analysis and do the designing of that structures. At that time only we will see that how we can create the .dxf 3D file in Etabs. At that time only we will learn that how we can create the .dxf 3D file in CAD software, and we will also see that a complete procedure how we can import that file. Now I am coming back to the procedure where we are seeing that how we can make the mathematical model in Etabs. Now let us look at the fifth method, which is Rivet Structure importing .exr file. Now this method is very important method, and we extensively cover this method in our course. And this method is widely used for making very complicated structures and all. For untypical structures, very irregular structures, dome-like structures. As you know that Etabs is not a modeling software. It is actually analyze and design software. So the command which you will get in Etabs is not sufficient to make very complicated structure and all. I will not say that it will not make the complicated structure, but if you're going to make it complicated structure in Etabs, it will take a lot of time for making. So what we will do, we will make complete structure in Rivet software, or we can say Rivet Structure software, that is more accurate to say. And after making that thing in Rivet Structure, we will import that file with the help of CSI Rivet plugin. You can easily create .exr file which can easily import in Etabs. So you have to download and install this CSI Rivet in Rivet software. After that you have to create .exr file, and that exr file will import in Etabs. In the module of the Rivet structure of this course, it has been already explained you that how you have to create the Rivet structure file of your project and how you can import that file into Etabs. Here I am going to give you a little bit information that how the Rivet structure file looks in Rivet and how the import works. In very short, I am going to explain you this all the process. So just I am going to open the Rivet software to show you that how the Rivet structure file looks. This is the Rivet structure file of one of the project which you are looking, and you can look at that. This is the 3D view which I am showing you, and this itself created in the Rivet software. Now after creating this file, you can import in Etabs. This is the structure plans, and you can go any of the floor here and you can just model what you want there in that floor. And this same structure plan will get imported in Etabs also. So what the elevations you have set in this structure plans, this also will get imported very easily in Etabs. So the Rivet software is very helpful for creating untypical floor plans, for making very complicated structures. If you have dome structures like that, so it is going to be very easy for making the complicated structures in Rivet, and you can import that file in Etabs. So how to create this Rivet structure file, you will be learning in this course in the module of the Rivet structures. So in the module of the Rivet structure, you will learn that how you have to create this structural file and how you can import this file in Etabs. In short, I am going to explain you that how you can import also this file in Etabs. So you have to go into Etabs, you have to get a new file here, take the unit, select the blank, go to the file, go to the import option. You can find here that there is an option of Rivet structure.exr file. You will click on this and select the file. So what the levels you have, you can edit it if you want here. So I told you now that all the floor plans will import in Etabs. So the structure plan which is created in the Rivet software, which you will just looking here, will get imported in this Etabs also. So if you want to change the elevations here, you can change this elevation also. I am keeping here same only. So material also. So if you have created the material in the Rivet, let's suppose that if you go to structures here, if you go to the columns option here, so here also you will get an option of defining the material. So if you created the materials here, then that material will also get imported in Etabs. So right now I am just keeping this as a by default, and the same section also. So what sections you have defined it in Rivet, the same section will come here also. Total floor sections and the wall section, how many you have created in Rivet will come here. Let's suppose that for the floors you have created 2-3 floor section like 230 mm, 200 mm, like that. If you created, then the same will get imported in Etabs also. Same thing for the wall also. If you created 2-3 wall sections, that thing also will come here. One very important thing that if you look at here, that total frame sections, in this total frame section your beam and column also will come. So this will come under the 1D, which is the one dimension element, and your floor and the wall section which will come under the cell, and this will be in the 2D element. Now the next very important thing in the control is your model length units. So this is the unit which is in Rivet software. So what unit you have created in the Rivet software, you have to input here. Now after that you have to give it this as a line close to the x, y, z coordinate, and after that you have to give it OK. It will show you some warning, you have to give it OK. You have to save this. Now you can look at that file is imported in Etabs. Now you can further apply the loads and you do the analysis and get the design. So no need to model here once again. All things will come here directly through the Rivet software in Etabs. Just now you have seen that how easy you can import the file through Rivet into Etabs. This whole thing is explained in the module of the Rivet structure, where you will find that how you can create the Rivet file and how you can import this file in Etabs. Now come back to the discussion where we were discussing that how different way of creating the analytical model in Etabs. Now come to the sixth method, which is your importing IFC file in Etabs. Now this method is very common to another software also, like BIM software, any other structural analysis software. So every structural analysis software and the BIM software has a capability to create IFC file, and you can import and export that IFC file through that. IFC provide an interoperability solutions between different software and applications. Do not think that this IFC is provided only in Etabs software. This is provided for every other structural analysis software also, like we have a Midas, we have a SAP 2000. So these are the important software which you look at here that is having a solution for importing and exporting that file with the help of IFC format. Even you will find this thing in Tekla also. So this IFC format establishes an international standard to import and export building objects and their properties. The full form of IFC is your Industry Foundation Classes. In the upcoming module of this course, I will explain you that how you can take a help of IFC to import your file in Etabs. Now we will take one project and we will try to understand that how this IFC file is very important when it comes to importing and exporting your file within two different software, and we can say applications also. We have come to the end of this lecture where we have seen that different way of creating the mathematical model in Etabs. So we have discussed a lot of methods through which we can create a model in Etabs. Now in your mind, one very important questions might be arising that which method is most common used method and easy method to do it. In this method, the most common used method is your through grid lines and by importing .dxf beam central line plan. So these two of the method is most common used method for creating analytical model in Etabs. And for the complicated structures where you have a very untypical floor plans, where you will find a lot of curves, domes and all, so very complicated structures, I will tell you that the best way of doing through the Rivet structure. I will not recommend you to use this method, because if you are not very good for making 3D in CAD software, then for you this method is very complicated and I will not recommend you to use this method. And importing IFC file is very easy method, like you can create, like if you are using the SAP 2000, you can create your DOM and you can import that thing in Etabs directly. So this method is also not used very much. So this method also I will tell you that it is very unpopular method, and no one in the consultancy for the simple project they will use this method. And for making DOM and all, at that time you can take this help of other software to make the DOM and you can import in Etabs. But if I will tell you for the simple structure, for the regular structure, this method is never used. The third method is also very rarely used method. In this course, except the fourth method, we will do one project for every method for creating analytical model in Etabs. So we will do through the grid lines also, through .dxa beam central plan also, by importing .wg dwg architecture plan also, and we will do through the Rivet structure also, and through importing IFC file also. The reason why I am making you to do one project for every method, because when you come to the real time practice in your consultancy or your practice by yourself, then for you the different option will be available for creating the mathematical model for any type of the projects. So when you get a different project, you will be having a different option also for doing that project. Also, if you have a complicated structure, then you will be having a good knowledge of Rivet structure, and you can do that type of the project also, like making a curve structures, making untypical floor plans, making the dome and all. You can easily create through the Rivet structures, and there you can create an analytical model of it and you can import in Etabs. Now I think that you have understood that what are the different methods are available for creating analytical model in Etabs and what situation we can use that type of the methods.